Hello guys, welcome to Quality and Welding Metallurgy. Today we are discussing on recommended practice for the welding of chromium-molybdanium steel pipe and tubing part 1. Joint design and preparation. Standard joint preparation such as those established in ANSI B16.25 are suitable for the base metal covered by document. The geometry of the joint should be minimize any notch conditions that might lead to stress concentration, sharp corner, or sudden change in section thickness of shape should be avoided. Preheating practice for tack welding are generally the same as those used in welding of the joint. Shrinkage the arc on the pipe or tube in area where the welding or heat treating will not remove the effect of the arc strike should be avoided. Root pass considerations. Root pass consideration: weld, bevel, and fit up should be assured complete joint penetration without excessive melt through. If a backing ring is used, the weld bevel and fit up must be permitted complete fusion of the weld of both the ring and the pipe bevel. Backing rings should not be used when service required extreme cleanliness or involve a corrosive environment. In such service, corrosive between the ring and the inner surface of the pipe or tube must be avoided. There are other applications such as those involving high velocity fluids or internal cleaning device like scraping pigs, where backing rings are likely to cause operational difficulties. In such cases, the root pass is made using GTAW or GMAW without a backing ring. Recommended procedure or such weld are given in ANSI AWSD 10.11. Recommended practice for root pass welding of pipe without backing. Two practices which apply to the root pass welding of the chromium-molybdanium steel should be considered. First, back purging of chromium moly joints is often required to prevent oxidation of the ID of the pipe. While there is not a fixed rules, the following common practice which are based upon the chemical composition of the filler metal are often selected. Under 4% chromium, no back purge. 4 to 6% chromium, sometime back purge based on service requirement. Over 6% chromium, always back purge. Second, for up to 2¼ chrome moly joints, some European fabricators use rutile coated SMAW electrodes successfully for the root pass in the welding butt joint. for standard wall piping, since these are not low hydrogen systems. Adequate preheating becomes very important. Such electrode had been commercially available in the US through the 1950s and had been classified by AWS as E78013B2 and 9013B3. Fit up. Fit up, addition to tack weld, joint alignment can be maintained by the internal or external support, jigs, or fixtures. They should be adequate for welding the joint is placed and minimize tensile and bending or transverse stress during welding. However, they should be flexible enough or should be removed during the course of welding in order to permit normal weld shrinkage and thereby the reduced stress that might cause cracking. External support should also be designed so that they do not interfere with adequate access to the joint during welding. The following are two common types of external supports for pipe and tube. The first, pipe clamps bolted together around each pipe and joined by bars with turnbuckles to adjust the load and to maintain a specific root opening. Second, U-shaped bridges that are welded to each pipe and cross above the joint with adequate space beneath them for welding. Preheating. Sorry. General preheating is recommended for all chromium and molybdanium steel and should be maintained throughout the entire welding operation. That includes period to any thermal cutting, period to stacking, and arc for tack welding and after weld interruption. In some cases, the preheat is maintained during interruption until some type of post-heating is started or both. The area to be welded or thermally cut should be heated to the minimum temperature suggested in Table 3 unless the applicable governing document required to higher temperature. Where dissimilar alloys are involved that require different minimum preheating temperature, the higher temperature should be used and maintained during welding. For some materials, maximum preheating or interpass temperature limits or both have also been established. Such limits apply primarily to materials heat treated to achieve specific properties such as low temperature notch toughness and or materials not suitable for high temperature service. Since the chromium molybdanium steel discussed in the documents are usually selected for elevated temperature service condition. Maximum preheat and interpass temperature are usually not required by metallurgical consideration but may be imposed because of the welder comfort. However, for dissimilar metal joints involving austenitic stainless steel, and nickel alloys. A maximum interpass temperature should be specified. Temperature lower than those given in Table 3 are recommended for the welding of the root pass with GTAW on low chromium alloys. Lower temperature permit better control of the shape of the root bed with lies likelihood of excessive reinforcement or melting through. The slower travel speed and the lower hydrogen and moisture level associated with the GTAW process justify some reduction in preheating temperature. Lower preheat temperatures are sometimes also used for tack welding, but these require careful inspection to be sure that the weld and the heat affected zone hedge are free of cracks. While welding must be performed in confined area, it may be necessary to use low preheat temperature for the safety of the welder. However, any deviation from temperature in Table 3 should be made in accordance with the applicable code, and they should be verified by both procedure qualification test and service experience. Sorry. Heating should be limited to the metal surface. Sufficient time and energy should be provided to permit uniform soaking of entire weld area. Heat should be applied by method that will produce uniform temperature around the joint. The width of the heated bend should be sufficient so that the required temperature is achieved throughout the thickness. Oxyfuel gas torch heating may produce excessive temperature gradient not only through the thick wall but also around the circumference. Unless heating is done always with uniformly around the joint, special care is required when the some surface is used for heating and for measuring the temperature. To be sure, the through heating and not just surface heating has been achieved, it is advisable to wait about 1 minute between removal of the heating torches and measurement of the temperature. This is not a problem when heating from the side and measuring the temperature from the other. Thus, when access and safety consideration permit, effective preheating can be achieved by placing the heating torch inside the pipe while welding from the outside. Another preheating method involves the use of wraparound electric resistant heaters. These heaters are typically used in conjunction with thermocouple attached to the pipe to monitor and control temperature. Such preheating provides uniform, continuous heat before welding, while welding in progress and during interruption. Use of thermocouple to monitor and control temperature also permit a permanent record of the preheat temperature to be produced the quality assurance purpose. However, the magnetic field produced by the flow of electricity through some configuration of resistant elements may produce arc flow while depositing the root pass. Table 3 suggests a minimum preheat temperature for various base metals denoted here. Temperature of heating cycle. Preheating is normally maintained until the welding has been completed. However, in interruption of the preheat may be acceptable after evaluating the situation. The effect of the interrupting the heating cycle are primarily mechanical in nature. A combination of residual stress, low ductility, and the presence of hydrogen may promote cracking at ambient temperature. Thus, when welding thicker section or higher alloy, chromium-molybdanium steel greater than 3% chromium, it is often advisable to retain the preheat without interruption until post-heating or post-weld heat treatment is started. Interruption of heating cycle when interrupting of after completing the welding of the chromium moly steel joint and prior to dropping the preheat. It is advisable to increase the temperature by about 100 degree Fahrenheit 50 degrees centigrade for last 15 minutes and sometime up to 4 hours to permit hydrogen to diffuse out, decrease the risk of hydrogen induced cracking. The need for such heating procedure increase as the alloy content and thereby the hardenability increases or the joint is subject to high restraint, extended time, higher temperature, or both should be considered whenever thicker material or low preheat temperature are involved. Such treatment is often called post-heating. Moisture and other material containing hydrogen. Hydrogen can be introduced into the arc from both water vapor and hydrogen containing compounds. If hydrogen is absorbed in the metal, it may interact with residual stress and cause cracking when the weldment is cooled. Therefore, interrupting the preheating cycle is safer when dry and clean base metal. Welding consumable and shielding gas have been used. When using the SMAW or FCAW process, or when there is some concern about hydrogen pickup, hydrogen can be reduced by post-heating as described in 5.2. Joint restraint, interruption of the heating cycle are more risky if partially complete weld is subject to bending movement for high axial loading. First, such bending movement may be encountered while transporting inadequately supported, partially welded piping assembly, such as moving them to heat treating or inspection area. The second, high axial loading is encountered during parentation operation called springing. This is used for closer weld of pipe maintained for elevated temperature service. The pipe is deliberately installed too short in order to compensate for thermal expansion. The tensioning device used to position the joint for welding should not be removed until the welding and all post-heating has been completed. Mass the base metal. Mass of the base metal increase the pipe wall thickness, increase both the restraint of the weld and the cooling rate for welding temperature. Thus, the weld area is subject to high residual stress at a time when it may be less ductile. For given joint, the greater the percentage of the weld that has been completed, the more nearly the strength and rigidity of the joint approach those of a complete weld. Therefore, any interruption of the welding is generally not permitted until some minimum amount of weld metal has been deposited. Wherever interruptions are permitted, the weldment must be cooled slowly and uniformly. Welding should not proceed until the preheat temperature has been re-established in the weld area. Weld area based on industrial experience. The following is suggested regarding entrapped heating cycle in the welding of the chromium-moly steel included in this document. However, it is emphasized that such general suggestions should be entrapped in the light of the factors maintained above the specific job condition. They should not be applied discriminately. For chromium-moly steel containing less than 4% chromium, the heating cycle may be entrapped provided the greater of two layers has been deposited or 1/3 of the groove has been filled with weld metal. In addition, the welding procedure should be employed adequate preheating, dry low hydrogen filler metal, post-heating and slow cooling to ambient temperature. For chromium-moly grade containing 4% or more chromium, the heating cycle should not be entrapped until the weld has been completed. Thank you. To be continued.